Okay. Welcome, everybody, to TechEd 2013. You are in the slide deck that takes a minute to get started. This is Build It Once for Both. We're going to be talking about writing and designing Windows 8 and Windows Phone 8. My name is Matthias Shapiro. My email address, I am a Windows Phone technical evangelist with Microsoft. Email address, Twitter account, you can yell at me either during or after the presentation. And we'll be talking, as it says there, we're going to be talking about building applications for Windows 8 and Windows Phone, best practices, and some good architecture. But to start out with, we need to understand that the app is dead. So this talk is over, and you have 74 minutes to yell at me. No, but what I mean when I say the app is dead, long live the product. We don't build applications that just live in one place. We build products. They live wherever our users need them to live. We have services that run in the cloud, and our client, which is what we're talking about here, our client needs to be wherever our user needs the client to be. It needs to be on the phone. It needs to be on their tablet. It needs to be on their desktop or laptop or whatever they need for it. And to this end, we need to learn to build across devices. Now, the good news for us as Windows devs or Windows Microsoft-centric individuals is that developing across devices is great because Windows 8 and Windows Phone go together like milk and cookies, like bread and butter, like Sid and Nancy. Well, maybe not that last one. But Windows 8 and Windows Phone are best friends forever. And there's, we're going to talk a little bit about the technology that underpins this buddy-buddy relationship. First is that Windows 8 and Windows Phone are built on top of the same Windows runtime kernel. Windows 8 is always going to have some things that Windows Phone doesn't have because you're talking about desktops and laptops and tablets. And Windows Phone is obviously a phone, so it's going to have some capabilities that we don't see in Windows 8. But the Windows runtime kernel is where what the two system platforms are based upon, and it has a lot of code, a lot of APIs that we can access, so that we're building on the same platform. Among those are networking. So our networking stack is going to be the same. We've got proximity, so NFC and Bluetooth are going to run the same way on much of the same code on Windows Phone as they do on Windows 8. In-app purchase is run on the same APIs, sensors, so accelerometers, gyroscopes, location, GPS, file systems, core app model, threading, all of this stuff and more is built into the WinRT kernel that Windows 8 and Windows Phone are running on top of. So let's talk a little bit about the ways that we can build across both platforms. There's actually a number of technologies that we can utilize in order to build across these platforms. The first one is JavaScript HTML5. Anybody here a super huge fan of JavaScript? Okay. I love JavaScript. I live it, I breathe it, and here's a picture of me working with JavaScript. That's not actually me. That's actually anyone who tried to build cross-platform applications in Windows 7 and Windows Phone 7. But fortunately, with Windows 8 and Windows Phone 8, this is not how things are anymore. Starting with the 8 series and Windows Runtime, Microsoft loves JavaScript, loves HTML5. And they work great on our platforms. If you're developing for laptop or for Windows 8, you have the benefit of using WinJS for Windows 8. WinJS gives JavaScript developers access to all the APIs that you would have if you're developing with managed code. And so you have access to all that hardware, all the hardware and the camera and access to creating new tiles in your application. It's really powerful and really great. Unfortunately, it's not the best thing to talk about if we're talking about building across devices because we don't have WinJS on Windows Phone 8. But what we do have is Internet Explorer 10. Windows 8 and Windows Phone 8 are both using Internet Explorer 10, and in fact, they're actually using the exact same rendering engine. So if you're building your applications for Windows 8 and Windows Phone 8, putting them inside of the application box, you're looking at the exact same rendering engine. And when my default mode is Windows Phone. I'm a Windows Phone technical evangelist. One of the things that gets me really excited is that if you're building inside of an application, you've got a web browser control, and that's where you're going to put your HTML and your JavaScript. And that's not running as some stripped down, sandboxed, half full version of Internet Explorer. It's actually the same instance that the user would see if they were to spin up Internet Explorer just straight off their home screen. So it's really powerful. I've seen a lot of great work come out of that. But if you're building across devices, JavaScript and HTML5 are definitely a decent option. If you want to explore that a little bit more, we have a great project called Yeti Bowl. Yeti Bowl is a Codeplex project where you can download the source and you can look at the same game, HTML and JavaScript, as a web app, as a desktop app, and a Windows Phone app. And I'm going to go ahead and jump out, take a quick look at that. So here's the code base. Here's the code base for that project. You see we have Yeti Bowl on the web, Yeti Bowl for Windows 8, Windows Phone 8. I'm going to have to give me a second as I move things over. I'm losing my mouse. Let me just try to duplicate my desktop. Okay. So this is Yeti Bowl running in IE10, and it responds to touch on my device. I have a touchscreen device, and we're just going to hit Sherpas as they come along, assaulting our tower here. And I don't normally use Google Chrome, but when I use it to show off Yeti Bowl. And so you can see it's a web standards-based application. It runs as a web app. If you want to have people just get to it and download it, it's a great example of how you build that web application that runs across multiple browsers. But it's also a great example of if we wanted to we have this great game, and it's a great web app or web game, and we want to take it and we want to run it inside of the Windows Store environment so that we can package it up, put it on the store, sell it, distribute it, just use that distribution model. This is the phone. So I actually have it installed. There's my Yeti Bowl application. I open it up, and you see we've added some extra stuff because we have a little bit extra that we can do in Windows 8. But it's the same game, it's the same code, all the same files, and it's running the same way. So now I've got it packaged up, I can sell it for $50 a pop on the Windows Store, and I can make myself a millionaire. And then lastly, it's the same thing with Windows Phone. I have Yeti Bowl installed on my Windows Phone application. It's, again, the exact same code. We're looking at very, very minimal code changes, mostly just to change the screen size affordance. And so we can play the game, we can package it up, we can put it on the store, and we can sell it as a Windows Phone game. Okay. Now, the perils. Okay, we're just going to go ahead and duplicate. We're going to keep this duplicated since I'm going to be switching back and forth so much between it. No. I'm sorry, I killed PowerPoint. So good jokes. Yell them out. Now's your time. Right. It's so fun. More than one, it seems. Okay, so we're just going to wait for my PowerPoint to spin back up. I'm sorry for that. You've got, come on. Do it again. Okay. Might have to stop some more processes. We're done talking about JavaScript, so I'm just going to close this. Ben. What's the, I've got to install on this machine. What's the button to switch over here? Number 1. Okay. Oh, please tell me my thing is installed on here. Oh. Where's the installation? Oh my gosh, this is a nightmare. Huh? Can you just give it? Oh, okay. I'm not in here. Oh, no, there I am. Okay. Okay, we're going to switch over and hopefully we'll just switch back to my presentation when, no. Okay, there we are. Skip back down. We're going to miss a couple of late-breaking tweets, or late-breaking tweaks that I've done to it, but we'll go ahead from here. This is still opening. This is unbelievable. Okay, so the problem with JavaScript and HTML is that because you're building inside a browser, you don't always have access to the Windows runtime APIs that we need available. And so if we do want access to all that, we have another option. We can build native. We can build in C or C++. One way of doing that is with third-party tools. So if you're a game designer and you want to build a game that runs on Windows 8 and Windows Phone, you can use a third-party tool like Unity. It gives you all of the textures and the character design and all the sorts of things that you want, and then you simply export it to Windows 8 and Windows Phone 8. Now, this might not be exactly the right audience for that. So it's worth mentioning that you can also build across devices natively using XAML and C++. Now, this isn't done frequently, but it is extremely powerful. And XAML and C++ require just the right combination of awesome and crazy. And for that reason, I consider it to be kind of the mixed martial arts of development. So does anybody know who that gentleman is? No? No? It's a Peter Tor, and he's a Windows Phone dev guru. He works on the Windows Phone team, and he's given a great presentation on using C++ in your Windows Phone applications. And the title there is actually a little bit deceptive because it's not just using them in your Windows Phone applications. His big focus is on C++ and the portability that C++ gives you. And so he does a lot of great work on showing you how to write C++ libraries that work across multiple platforms. It's a really great presentation. However, if you hate sitting in a seat and watching a video and you'd rather see it live, we also have C and C++ in your Windows Phone applications. This is tomorrow, Wednesday, at 10:15 I think it's in this room. So, but what I'm going to be talking about in depth in the demo that we're going to be looking at is building across devices for XAML and C#. Managed code, building across devices. So let's do a quick overview. What do we need in order to make our applications work and make them powerful when we're doing cross-device development? We're going to talk first about developing across devices. We're going to talk a little bit about MVVM best practice, portable class libraries, which makes this story just so powerful. A little bit of code sharing do's and don'ts. And then we're going to talk briefly about designing across devices. I'm going to look at some UX similarities between Windows Phone and Windows 8. And I'm going to give a little bit of XAML control guidance because we have different controls. And I'm going to talk about how we navigate that. So first of all, that was one of the things I changed. MVVM stands for Model, View, View Model. How many people here have worked with MVVM before, or in MVVM? Not a bad crowd. Good. So you can go to sleep for the next 5 minutes. But what Model, View, View Model stands for is, well, yeah, MVVM stands for model, view, view model. Go into that in just a moment. But what it gives us, the reason we would use it is it gives us a couple of things. It gives us some design and development separation. I do most of my design and most of my development together by myself, but I still find this to be extremely useful because it means I can shift into a mode. I can go into my XAML and be, okay, right now I'm working on XAML. How does my XAML work? What do my bindings look like? How am I laying things out? And then I shift over into development. All right, now I'm building my services. I'm building my commands and my properties. I'm putting in my application logic. I like having those two sides of it separated out because it means that I can focus on what I'm doing without having to shift between two modes. It also gives us a lot of code reuse. We're able to reuse models across multiple applications. We'll look a little bit of that. But we also get a lot of reuse out of our view models. If they're built correctly, our view models can be reused across multiple views and even across multiple applications. Which brings us to multiple views on the same logic. Just because you may have a scenario where you have two completely different types of users that are interacting with the same application logic, the same models, the same the same application. They need to look at the data in a very different sort of way. Model view model gives you the opportunity to build something like that fairly easily. You can build your view model and have it pull in a list of things, apply some logic to it, but you can then display it two different ways using two different views for your two different audiences, or three or four. Finally, it gives us view logic testability because the view connects with commands and bindings. It means we can run unit tests on our view model, and we can test all of our interactions and all of our application logic. So, I'll talk a little bit in depth about what model view model is. The model part of model view model is a simple representation of data. In many cases, this is going to be a one-to-one property relationship between the entities in your database. It usually has very little logic or functionality. It's just kind of, people refer to it as a dumb model, and that's not a bad way of looking at it. The view model is where the magic happens. It holds your application logic. If you have service calls, that's where you're going to be making your service calls. If you're doing data management or storage, the vast majority of your work is going to be done in your view model. When things change, your view model manages the changes. Your view model is going to be, usually is going to pull in representations of your model. We'll see this in the demo. And then managing those, saving them back out, that kind of thing. And then lastly, we have your view. The view is what the user sees and what the user interacts with. It is entirely your user interface. When you open up your application, Windows 8 or Windows Phone, you're navigating to a view. You're not navigating to a view model. So it's everything that your user sees and interacts with is considered your view. Now, how does the view interact with the rest of this? How does the view interact with the view model? There are a couple of ways: data binding and commands. Data binding is a really great system where the view model has is an implementation of what's called iNotify property changed interface. And when our view models implement this interface, we can create properties, and when those properties change, the changes are sent off as a message to our view, as long as our view is bound to it. So if we have a text box and we want to populate that text box with some sort of information, maybe a string that exists inside of our view model, we can just say the text box text is equal to a binding of a view model property. Now this is great because if we go out to a service, we bring that information back, and it changes kind of underneath the view even while the user's sitting there, all of the updates happen automatically. We don't have to go in and say, oh, update this UI piece and this UI piece and this UI piece, and it all just updates automatically. But even more than that, if the user's in there and they're in the text box and they're like, well, my name isn't Jane, it's Matthias. They type into the text box, and you can do two-way data bindings. So that when you type new information in the text box, you don't have to tell, the view doesn't need any extra code to go to the view model and say, hey, my property has been changed. It updates automatically inside the view model, and we can even listen for those changes in the view model and say, when you hear a change like that, go and save this to a database or go and update this at a service. The other way the view can communicate with the view model is with commands. And commands are sort of a light property that we can bind in our view. And they are initiated by some sort of event within the view. So the press of a button, we could initiate a command, and it'll run some code inside the view model, and the view model can act upon that. So between data binding and commands, there are other ways if you want to dig really deep into MVVM. I would suggest taking a look at Prism or MVVM Lite, but those will have a lot more for really heavier applications. But this is the basic ways that we set up an MVVM app, with our view model holding instances of our models, and our views communicating with the view model using data bindings and commands. So how does this MVVM fit into a build for both structure? Well, my build for both structure, what you're going to see here and what I'm recommending, starts with a portable class library. Portable class libraries are relatively new to .NET, but the basic idea is that you have a portable class library and you're building one source code, it outputs one DLL, and that's all you have to manage. For your application, portable class libraries are a great place to put services, network calls out to, for example, RESTful services. View models, very large parts of view models can usually live inside of portable class libraries. The two ways to do that are to have them limited so that they can be built upon, or to have them as abstract view models. And then lastly, our models are going to be built in such a way, like we said before, they're dumb models. And so they can live in a portable class library. They don't have a lot of application logic. There's nothing inside of the OS itself that they need to interact with. And so portable class library is a great place for them. But portable class library isn't a solution for everything. There are some things that it can't do. One of those things is, for example, it doesn't have access to file I/O, so you can't do storage with portable class libraries. Well, storage is still something we want to do within our view model, and so we can share view models with a functionality called add as link. And in there, we would put things like storage, maybe message box alerts, other OS-specific functionality that we might need is going to go inside those shared view models. And then we can maintain a single source that we can use across both of our applications. And then lastly, some things are just going to have to live inside of an individual project. When you see my application or my demo, you're going to see a portable class library project, a Windows 8 project, and a Windows Phone project. We're sharing view models in a couple of different ways, but a lot of these projects, a lot of the stuff is going to have to live in specific projects. We talked a little bit about views and how views are UI specific. Well, the UI of my tablet is so substantially different than the UI of my phone that it's going to be more pain than benefit to try to share the XAML. So I recommend doing XAML specific views for your phone and for your tablet or for your desktop or laptop. Application lifecycle is going to be different between Windows 8 and Windows Phone. And so we're going to want to manage that on an individual project basis. Also, navigation is going to be a little bit different. And so I tend to put those into, you could build a single structure that manages navigation for both. But for the sake of simplicity, I like to keep it separate in my different projects. And so this is how our build for both structure interacts with our model view model. It's kind of two architectures that kind of meld together. We've got our models down there at the bottom in our portable class libraries. A lot of our view models can also live in our portable class libraries, but they also can live inside the project as shared view models, shared files. So in some cases, your view models, your interaction may be so different on the phone, between the phone and your tablet or your laptop, that you want view models that are specific to a phone or specific to a laptop. And that's fine too. You could have a view model that is only phone or only Windows 8. Lastly, the view part of the view model is almost exclusively going to be living inside of each individual project. So that's a lot of boxes. I put a lot of things in a lot of boxes, and you probably have this idea in your mind, especially if you haven't done it before. It's kind of, you feel like it's kind of vague. It's almost there. You sort of know that it relates to something in the real life, but you don't feel like you've really got it. You know it means something. Does anybody know what this is from? Yes, Close Encounters of the Third Kind. Roy Neary carves out his mashed potatoes, and he knows that it lives somewhere, and it means something, but he doesn't know what. So hopefully our demo is going to solve that problem. A little bit of background on this demo. This demo is using something called Philips Hue. This is a Wi-Fi. What you see here is the little white circle is a Wi-Fi bridge that connects. It serves up a RESTful service for LED bulbs, and that's why we have this cute little tree down here. I'm going to switch over to my application. I'm going to hit run. And so what we have here is an application where we can, all of this is done using bindings and commands. And I can change the colors with very simple, and this is all two-way binding that we've got going on here. And so you can see that we've got this on Windows 8. We also have it on Windows Phone. Let me open up. We're going to restart my DVI out. Okay. So we also have this on Windows Phone. I can change colors. I can change the brightness. And what you can see is that as I'm doing that, it's updating inside of my Windows application. And so we've got this great system where we're pulling back and forth lights between the Windows Phone and the Windows 8. We can do things like cycle through the lights every 5 seconds on a timer. The lights are just going to cycle through. And you can see all of that is being updated inside the Windows 8 application. So very cool, very fun. And as we go through the code that's related to this, we're going to finally see that abstract model kind of play out in the real life. Thank you. Okay, so I'm going to be switching back and forth between my my application here and, I need to get out of this thing. There we go. We're going to be switching back and forth between my application and the slide deck. So this is going to be fun. Okay. First of all, I do want you to keep this, if you come out of this talk with absolutely nothing else, keep this in mind, because this is the basis of how I'm building this application. And this is a great way to think about our application, how to share code, and how to build in a way that's reusable and helpful. So we're going to start with a little bit of audience participation. With this application, with MVVM, if you've worked with MVVM before, what kinds of models let's start with models. What kind of models do you think we need for this? Light bulb. We need something that represents the light bulb that we're trying to change. Anything else? What about view models? What does our view model need to do? Well, it's going to have a couple of instances of this light bulb. We need 3 light bulbs. We've got 3 light bulbs we need to control. We've got 3 properties up here that we need to manage. So we're going to have 3 instances of that model property. We're going to need to communicate with the light bulb somehow. So we need some kind of service. We need commands. We need some way of both talking to the light bulb and getting information back from the light bulb. So we're going to need an update light. We also need a get light. And so those are 2 different commands that we're going to need. And lastly, we need our UI and controls. We're going to walk through all of this. So here's how I have it set up. We're using the Windows Phone as an example because I don't have enough space on the screen to use both. But we've got our UI and controls. That's all of our view code is inside the UI and controls. I've got my Hue control view model with a couple of Hue lights living in there. I have 3, but I didn't have room on the screen for 3. And then we have our update light command, we have our get light command, our hue service. And the interaction between all these things works like this. We've bound our hue control view model to the data context on our view. So that way, the view can see all of the hue lights as properties. It can see all of the commands. It has access to all of that. Whenever a hue light changes, the data binding is going to update that change inside the UI without any other code. When we change something on the UI, when we change one of those slider properties, it's going to call the update light command. And the update light command is going to talk to the hue service. And it's going to say, hey, I have these new light properties, and I would like you to go and tell the light to change. And so that's what it'll do. It'll go and it'll tell the light, react to these new properties. But for things, especially things like the animation that you saw there, for that, we need a get lights command to let us know across all of our devices, oh, hey, I want you to update. Let me know, how does the light look now? How does it look now? How does it look now? How does it look now? We want to keep that updated so that we have a synchronous nature between our devices and our lights. So that's going to be running. We're actually going to run that not on any sort of UI, just in the background. So we'll send it to the hue service. The hue service will query each of the lights, say, what do you look like? It'll send that information back to the code that we have inside of the getLights command, which will then update each of the hue lights, and the hue lights complete the circle because every time they get updated, my UI gets updated automatically. So to start out, let's talk about portable class libraries. Portable class libraries are great. You just start up a new project, you select a portable class library, and you can select from a bunch of check marks which platforms you want to support. You end up with one source, one project, one binary on multiple platforms. One addition I'd like to add to this is that portable class libraries, we have a lot of great beta libraries that work with portable class libraries, and my favorite is the HTTP client PCL library. Here's the NuGet for it, install package, microsoft.net.http-pre. And it's just a great little library for sort of ironing out the differences between Windows 8 and Windows Phone so that you only have to worry about one HTTP client that you can use across all platforms. So here's what my control view model, my portable class library view model looks like. It has 3 instances of my hue lights, 3 commands to update my lights, and then a hue service instance. Now, I could have done it so that I had update light and then handed it a parameter, one command with multiple parameters. And that would certainly be a more robust solution. But I felt that I'm hoping to get this code out, and I felt this was a slightly more simple solution, a little easier to implement, easier to look at, especially if you're new to MVVM. So all of this is living inside of my portable class library, and we'll switch over so you can take a look at what I have. Here are my 3 projects, my portable class library, Windows Phone, and Windows Store. And I'm just going to pretend to add a new project so you can see how easy it is to build a new portable class library. Where is it? For F#, VB, and C#, you just do that. If we add it that way, you see we have those check marks. We can simply select the different frameworks we want to support, and away we go. Our portable class library works across all of those frameworks. But here's my portable class library. I have some helpers, some models, services, and my view model. And here's the view model that I'm talking about, my hue control view model. If we open it up, we can see that I have that iNotify property changed interface that I was talking about. And that means every single one of these properties is bindable. Now, a lot of these are kind of background properties. We're not really interacting with them in the demo, but they're, of course, still important for it to work. We have our different hue lights. You see every time, and this is what a property change property looks like. It's just a simple private-public property, and then every time you change it, it does a raise property changed, which is what the iNotify property changed is all about. So we create our view model. It implements iNotify property changed, which I tend to put at the bottom of my code. And it's simply an event handler, and a method to raise the property. So that's all we need in order to make binding work inside of our views. So back to our structure. Our control view model handles those commands, handles that light, handles the service, all put in there, and then we can use all the functionality that we've built into our hue control view model on our phone and on our Windows 8 device. But there are going to be some limitations to our portable class libraries. It's not going to have any file I/O access. So any use of the storage APIs is going to be off limits. It can't perform specific OS functions. So things like doing alerts, doing that message box, tiles, accessing the camera. These things are implemented differently on Windows 8 and Windows Phone, and as a result, our portable class library can't access them. From this particular demo, one thing that I don't have access to is my dispatcher timer. I wanted to run it so that I got an update from my lights every second, and so in order to do that, I need a timer. In order to do the animation, I need a timer. So we can see that the view model that I have inside my portable class library is not, it doesn't have all the functionality I need to make my application work. And so what I've done instead is I have a shared client view model. This means I'm writing all of my code into a single file, and I'm sharing that file across two projects. And so what we need inside of my shared client view model, we need our getLights command, because the getLights is running on that dispatcher timer. And I'm actually storing, we don't see this in the demo, but I'm storing user storage, and I'm storing the status of the lights inside the application. And so all of that storage needs to happen inside this client, the shared view model that lives on the client, rather than the one that lives in our portable class library. And so in terms of our overall structure, that's where these things live. And let's switch back over the code and take a look at what that means practically. So I'm going to delete that, and I'll show you why in just a moment. So this is my Hue client view model, and you can see that it's a subclass of my Hue control view model. So this is the Hue client view model. This is what I'm actually binding the data context of my view to. And so it has all of the properties that we had in our control view model, the one that lives inside our portable class library. But in addition to that, it has my dispatcher timer. It's running code from my dispatcher timer. It has access to and all the commands that need to run that dispatcher timer live inside here. So as well as my storage code. So switching back. Oh, I guess I didn't need to switch back. But the way that we share these view models is using this functionality called add as link. And so that was why I deleted the view model from my Windows 8 application, is because as a Windows Phone guy, I subscribe very much to the mobile-first form of development, build for mobile, and then expand upon that. And so I built my client view model inside of Windows Phone first, tested it there first, and then brought it over to Windows 8. Well, the way we bring our view models over so that we're using the exact same code and all of our updates propagate across all of our applications is we go to Add, Existing Item, we select our view model, and then down here at the bottom, we have this little Add button, and then Add as Link. And so that's what I select. And when I do that, you can see I have this little blue icon there. And the little blue icon means that this is a file that we're sharing with another project through that Share as Link functionality. And so it means that whenever I open up, I can close the application here, and I can open it up in Windows in my Windows 8 project. And when I do that, my IntelliSense reverts to everything that I have available in Windows 8. So I can go and I can go ahead and I can make sure that all of my Windows 8 code is working appropriately. And if I want to check it with IntelliSense against Windows Phone, I can simply close it and open it from the Windows Phone perspective. So that's great. That's helpful. Now we have one view model that we're binding to across multiple platforms. We're using it in one file, and every time we change that file, all the changes propagated across both platforms. But there are some instances where we still need a little bit of developer magic in order to manage small code differences between Windows 8 and Windows Phone 8. The dispatcher timer is a great example of that. I've got my dispatcher timer here. I create a new one. I set the interval, okay, check every second for new status on my lights. And then every time you do a tick, I want you to hit this event handler. Unfortunately, the event handler looks a little bit different in Windows 8 as it does in Windows Phone. In Windows 8, the event handler takes in two variables, object and object. In Windows Phone 8, it takes in object and event args. So we look at this and we decide that everything is hopeless and we give up. Or we can use if conditionals. If compiler conditionals allow us to say, okay, when you're compiling the application, I want you to use this line of code if it's compiling as Windows 8, and this line of code if it's compiling for Windows Phone. netfx_core is the conditional for Windows 8, and Windows_phone is the one for phone. And so here, all I have to do is a single line of code. For Windows 8, we point it to a Windows 8 specific event handler. For Windows Phone, we point it to a Windows Phone specific event handler. And I could take those event handlers and encapsulate the entire thing in an if conditional. But it doesn't hurt anything if it's just living there as orphan code. So I decide to try to keep it as clean as possible and just take that one line and use the if conditional on that. So the last bit of our structure is so we've talked about our portable class libraries, how we can build entire libraries with great functionality that can work across both platforms very easily and very simply. We've talked about how we can build shared models that have to live in a project but can still share exactly the same code across both platforms. Now we're going to dig into what we have to do specifically for Windows 8 and Windows Phone 8 that's a separation between the two platforms. The first thing is that the separation inside of the XAML is basically just the XAML. The important things, the data bindings, the commands, these are similar, either identical or very similar across both platforms. And so they're binding to exactly the same view model, to exactly the same properties. And if we're updating those properties appropriately, everything is working the exact same way on both platforms. So let's look at data bindings and command, a little bit of code for Windows Phone, and then we'll look at it for Windows 8. The first thing, let's look at bindings directly to a property. Here we've got the sliders are what we're interacting with, and we want the positions of the sliders to reflect the red, green, blue values and the brightness values of our lights. So all we do is we take our slider and we assign the value of that slider to our hue light .red. And so that way, every time that hue light object gets updated, the slider gets updated as well. Now, because we have it as a two-way mode, that means every time we update the slider, it goes back to the view model and updates the property of that hue light inside the view model. And so we get all of that, the synchronous updating between our UI and our view model is just right here in that one little binding. But for things like, one thing I don't want is that every time I change the value, I don't want it to make a service call. That's a lot of service calls because the value changes very easily and very quickly. Instead, I want it to do a service call when I make a command. So I'm going to have, I change the slider, it goes up and down, I decide that's where I want it, and then I let my finger off of it. That's when I want it to make that update to the light. And so with Windows Phone 8, we can do that using this thing called an event-to-command behavior. And I can show you how to create an event-to-command behavior using blend as a secondary option. So here is my... Oh, I need to change this. There we go. So here's Microsoft Blend, and here's my view inside of Blend, inside of a great WYSIWYG designer tool. If I select my slider, you can see the slider down here, and it's got an event command on it. And I can just go in there and say, here are the possible events that I might want to run this command off of it. I can run this command when I load my slider, every time the mouse leaves the slider, but in this case, I've got it on my mouse left button up. If I need to create a new event to command, I can go to my Assets tab up here at the top, down to Behaviors, and we can simply drag and drop the event to command onto any UI element. And it'll give us all the functionality, all of the events possible for that UI element become available to our command. So we'll delete that. There we go. Switch back to our slide. So that's the simple, we talked about two ways of interacting between our views and our view models. The first one being binding, the second one being command, and we can see both of those here. But with bindings, we can do some very powerful stuff as well. And one of the ways we can do that is using converters. You see the icon in the background. You saw that as I updated the light, the icon color updated. Well, I'm not running any code specific to my Windows 8 or Windows Phone in order to do that. That's all being updated by a binding. And so my view model doesn't have to know anything about color. It doesn't have to know anything about the solid color brush or the variable color brushes or any of the UI elements that interact in order to make this update a reality. The view model can be blissfully ignorant of that, and we can manage it all inside of our project, the view portion of our project. Let me show you what that converter looks like. Here's my hue to light converter. And all it does is it takes in a hue light object, and it says, what's your RGB value? Let's turn that into an actual brush that we can color the elements in our UI for. And so what we see here, let me actually open this up. You can create converters that run on Windows 8 and Windows Phone. I find it to be cumbersome. And so I use mostly the same code, but just in different files. So here we have our color converter for Windows 8. But as you can, as you can see, we simply create a solid color brush. We set it to white as first, and then if we have no hue light property, if there's no binding property there, we just return it. And then we grab our hue light value that we've bound to, and we grab the red, the green, the blue. We turn it into a color, and we bind it to oh, no, don't do that. When this stops trying to make sure that I'm following good coding practice. Here, I'll show you one of the. I get very, very excited about this, and part of the reason is because when I was building this application, I was not certain that I wanted to do. I didn't know about the icon. That wasn't my first way to go. My first way to go was actually to take this element, this light, the color up there, the text. And what I did was I simply bound the text to the same thing that I bound my light to. So this fill right here has the hue light, it has the converter. What I had originally was I had my light background set to exactly that property. Let's save that. And now if I run my application, I get an error. What's my error? Foreground is, I've set the property twice here, so we'll just change that. Yeah, yes, I know. See if I can find it quickly. It's down at the bottom. Okay, so I've set my foreground 2 times. We'll fix that, and then we'll run our application. And what I think is so fun about this is that I didn't have to do any updates to my background code. I can take this property, this hue light, I can set it to any UI element that I want, just using that converter and using that binding. And to me, that's enormously powerful because it means when I need to make those changes, when I decide, I don't really like having my color, the color of my text. I need something else. I need something better. Then it means that I don't have to make any changes to my view model. All my changes, I change a single binding inside of my view, and I get that great, the great new view, the way I want it. So data bindings and commands in Windows 8. The data bindings are working exactly the same way. We've got our slider, we've got our value, our hue light, and we've got that two-way mode. The commands are a little bit different because we don't have that event-to-command behavior that we had in Windows Phone 8. And so what we do instead is we create a pointer exited, because the slider in Windows 8 is different, the control is different, it runs on different events. We create an event handler for the pointer exited event. And inside of there, we are still running that command. And so, again, between Windows 8 and Windows Phone 8, we don't have differences in our view model. The differences are in our view. And again, with the path, exact same binding, using the same converter code. So within our view, I'm going to talk a little bit about the differences. Between our views, what do we have to keep in mind between Windows 8 and Windows Phone, building Windows 8 and Windows Phone views? Well, they're actually really, really different form factors. A phone is an extraordinarily mobile device. It's something people use when they're standing, when they're sitting, when they're moving around. And a tablet or a desktop or a laptop is a much more stationary device. It's got a much bigger screen. We're talking about 2 vastly different form factors. With Windows Phone, it's almost always being used in a vertical or in a portrait mode, and so we're looking at a lot of vertical scrolling. In Windows 8, it's always being used in a landscape mode, and so we can look at there are a lot of great applications that use that landscape mode to do horizontal scrolling. Windows Phone has only 3 different resolutions, whereas Windows 8 has infinite number of resolutions. And then lastly, Windows Phone has extraordinarily limited screen space. And so you can see there was absolutely no way I was going to interact with 3 different lights in a single screen on Windows Phone, whereas I do have that luxury in Windows 8. So we have despite this, there are a lot of similarities between Windows 8 and Windows Phone. We've got a lot of similar UI elements. We have the tile structure that's the same. We have alerts and push notifications that work much the same way. But one of the big things we need to keep in mind when we're building our views is that we have a lot of control differences. A lot of controls that are available on Windows 8 are not available on Windows Phone 8. And this isn't a bad thing. Because the form factors are so different, we need to really kind of train ourselves to keep in mind what is our user trying to do? What is the overall goal of this application? And how can I translate those goals into views that are specific to my form factor? Now, one example of differing controls that deliver similar user experiences, with the Windows 8, we have a semantic view. This will take a list of items, group them into some sort of logical grouping. In this case, we have a cookbook that has a bunch of different recipes, and we've grouped them into different regions: Chinese food, French food, German food, Indian food. And the user can actually even use if they have a touch screen, they can do a pinch zoom in on one of these, let's say French food, and they'll go into a better view for that, more detail, and then they can do another zoom out. They can tap on it to go in. It's a really flexible, really powerful control, but it doesn't make a lot of sense on Windows Phone. So instead, on Windows Phone, we need to think about, okay, what does the user really do? What they're really doing here is they're managing a grouped set of, they're trying to find a way to navigate through a grouped list. Well, what's a good control for managing a grouped list in Windows Phone? Anybody? The pivot control, yes. The pivot control gives the user, instead of trying to use 2 fingers to navigate, it's a single one-fingered swipe. And it gives them quick access to their lists and quick access to their groups. They can switch back and forth between groups. A very powerful paradigm, just different controls to manage the same paradigm. Another great control in Windows 8 is the grid view. You'll see this if you have your Surface that you hopefully just bought, or your multiple Surfaces. And if you open up your people page and you've logged in, you hopefully have lots and lots of people in there, and it's a lot of horizontal scrolling, or you can navigate them alphabetically. You can press on the A group and it'll bring you to an alphabetical list, and you can manage, you can navigate all the way to T or Z instead of just the simple horizontal scrolling. So this does 2 things that are specific to Windows 8. It does that, it has that horizontal scrolling mode to it. And it has a lot of information, takes great advantage of the real estate that we have. So with enormous lists, if there are any Windows Phone sorts of people here, what kind of control do we have in Windows Phone that manages giant lists? The long list selector. And it works much the same way. And so 2 different controls monitoring a single paradigm that can be managed using a single view model. And so in terms of the platform-specific, because that's what we're talking about, what is platform-specific? What do I need to make sure that I'm managing on a project-by-project basis? Totally different XAML. If you are awesome enough to create one XAML to rule them all, then Godspeed to you. But what I found is that different XAML is the solution to this problem. Different controls to manage the different form factors on Windows 8 and Windows Phone. But keep in mind that we are still using the same data bindings. We're still using the same commands for key interactions. And so that's where the build for both story is really, really powerful, and where the views and the specific code, then the project-specific code, really interacts in a powerful way. Lastly, we're going to keep, I really want to burn this image into your mind, is that we have this really powerful model and building for both, where we have the portable class libraries that manage our models, view models that are flexible enough to move, to do part of them in portable class libraries, and maybe you have an application where you can do your entire application, or your entire view model in a portable class library. But when that's not enough, we have shared view models where we can share the same file across projects. And then lastly, our views, which manage everything that the user is going to see, the user is going to interact with. So for additional content on this, I recommend going to a couple of places. There's commands, relay commands, and event to commands. Commands are one of the harder aspects of MVVM to grasp. But a gentleman named Laurent Bugnon has written a series of on commands and MVVM in general. It's in the MSDM magazine. You can do a search on that, and you'll find it. And he also is the author of a very, very powerful library called MVVM Lite, which takes some of the more complex aspects of MVVM, pulls them down. He gives you, I use it all the time in part because he gives you a lot of snippets. And so instead of having to write out my properties again and again and again, I hit MVVM L, and I get a bunch of options for creating my commands and for creating my properties, all the code that I need to run it quickly. A couple of build talks that you might be interested in is designing awesome XAML apps for Windows 8 and Windows Phone 8, and also creating cross-platform apps using portable class libraries. So, oh, these are not hidden as they once were. So for additional resources, I'm sure you've seen this slide before, but here they are. And please fill out your evaluations, and I love to take questions. The deeper, the better. Thank you for your time.